Welcome to this explainer. Today, we're tackling a massive, absolutely crucial security risk, giving AI agents direct access to your files and your shell. We're going to be taking a close look at a powerful new tool called CageBro. And honestly, it completely changes the game for how we handle agent execution.
So, let's dive right in. How do you actually let an agent write code and browse the web safely, especially when traditional sandboxing just absolutely crushes your RAM? I mean, if you've ever tried building a multi-agent system, you know the struggle, right? You're constantly trying to balance giving an agent deep system access against the terrifying possibility of a runaway agent accidentally wiping your hard drive.
Here's our roadmap for today. 1. The AI agent problem. 2. Enter CageBro. 3. Why this project matters. 4. 2 workspace guides. And 5. Inside release 0.2.0.
All right, section 1. The AI agent problem and enter CageBro.
Okay, so the crucial point here is that AI agents absolutely need a safe execution environment to be useful. But the current solutions we have, well, they're built for whole applications, not single agents. The David versus Goliath stakes here are just brilliant. Look, standard Docker containers work, sure, but a Chromium-based browser container, that eats up roughly 2 gigabytes of RAM and takes seconds to start. That's incredibly heavy. Meanwhile, CageBro, which is compiled as a single Rust binary, uses just 100 megabytes and loads in about 1 single millisecond. That's literally a fraction of a blink.
What does that actually mean in practice? Well, it means on a tiny, super cheap, 1-core, 1 gigabyte virtual machine, you can smoothly run 20-plus concurrent agent sandboxes. If you're an enterprise, that translates to massive, and I mean massive, infrastructure savings. And if you're an indie dev, you can run a full multi-agent stack on a $5 a month VPS. No way, right? But it's true.
So how does CageBro actually pull this off? Think of it as a highly specialized workspace jail. The philosophy is surprisingly simple. You completely turn off the agent framework's native tools, you plug in the CageBro MCP server as the absolute only way the agent can touch files or run commands, and then CageBro locks that agent into a single folder it cannot escape. It's process-level isolation instead of a heavy, clunky VM sandbox.
Moving right along to section 2, why this project matters.
Let's look at how this builds into real-world applications, especially if you're building stuff like agentic trading platforms or compliance workflows in financial services. In regulated industries, data privacy is everything. You just can't send sensitive data off to some third-party cloud sandbox. And CageBro was designed with exactly these environments in mind. Because it's completely self-hosted, your data never actually leaves your network. Plus, every single action the agent takes goes through a structured REST API, meaning it is fully auditable. You can even easily insert a human in the loop where an agent proposes an action, a human says, "Yep, looks good," and only then does CageBro execute it. All of this while giving you that massive density for running dozens of parallel agents securely.
Now, here's a real game changer, the flexibility. CageBro is entirely framework agnostic. It plays beautifully with LangChain, CrewAI, OpenAI function calling, or totally custom agents. You get a standardized runtime across your entire stack, complete with an anti-detection browser, code execution, and a fully interactive terminal. And you get all of that without any vendor lock-in whatsoever.
All right, section 3, your 2 workspace guides. Let's talk setup for new users.
Let's look at exactly how you set this up to keep your new agents neatly confined. Scenario A is for a fleet on one box. Let's say you want to run 20 agents on a Mac Mini. Step 1, you run one instance of CageBro per agent in its own designated folder. Step 2, you point the agent to that specific CageBro port and deny its native tools. And Step 3, to scale up securely, you give each agent its own OS user. That way, the underlying operating system permissions hold the line, enforcing some really hard multi-tenancy.
But, maybe you're just testing an agent locally. That brings us to scenario B, the remote sandbox. Here, you run your agent natively on your Mac, like Claude desktop, but you pipe its execution over an SSH connection right into a throwaway Linux VM workspace. All your agent's file and code work happens completely inside the VM. Your personal Mac file system is literally never exposed to untrusted code. And to reset the whole thing, you just wipe the folder in the VM. It is incredibly clean.
Which brings us to section 4, inside release 0.2.0.
Technically speaking, version 0.2.0 is the very first release that truly locks down the security model, making it the one that really matters. Transparency is key here.
The system reliably blocks an agent from reading or writing outside its specific workspace, and it immediately kills runaway resource hogs. But, and this is important, notice what CageBro does not do. Network exfiltration and kernel exploits, those are still on you. This is by design, guys. It means you must pair CageBro with a proper deploy layer like a host firewall or a virtual machine to get true, bulletproof security for hostile code.
The big under-the-hood technical upgrade here replaces older native execution with Linux Landlock and rlimits. This is absolutely fascinating. On a Linux system, before the process even executes, Landlock steps in to strictly confine the file system, while rlimits cap memory usage, file size, and CPU wall time. It's security built directly into the kernel mechanisms, meaning your agent is handcuffed before it even takes its first breath.
Beyond the security upgrades, this release also brings an orchestration API that's compatible with standard cloud sandboxes, making lifecycles an absolute breeze to manage. It also introduces the incredibly cool ability to take file system snapshots. You can literally capture an agent's workspace and fork it into independent copies. It's perfect for workflows that require parallel exploration. Add in some new startup locks to safely prune stale data, and you have got a remarkably mature infrastructure tool.
So let's pull all this together. With all this raw speed, hardened process isolation, and an incredibly lightweight memory footprint, CageBro completely redefines what's possible for local and on-premise agent infrastructure. The only question left for us to answer is, with 1 millisecond start times and total workspace control, what will your multi-agent fleet build today? Thanks for joining me on this explainer, and I'll catch you in the next one.